Hi, everyone. Welcome to episode 8 of Cosmos Crusaders. For this episode, Gok and I had the privilege of interviewing Kyle Kabasares, who got his bachelor's in physics at UC Merced and is now finishing up his PhD at UC Irvine. We had a really great time talking to him, and I think both of us learned a lot. But we're just going to go ahead and before we start our episode, talk a little bit about some of the takeaways that we had from our conversation with Kyle. So, Gok, if you want to go a little bit into that.
Yeah, Kyle was a really interesting person to talk to for sure. And we both learned a lot from his interview. And one thing in particular that he mentioned that he wanted to talk about that I thought it would be good if we highlighted in the intro was this article that he sent to us. It was on NPR and it was called Southeast Asians Are Underrepresented in STEM. The label Asian boxes them out more. And it was by Deepa Shivaram. So the article, which was very interesting, I learned a lot from it. And sort of its main takeaway was that many Southeast Asian American groups, including Hmong, Vietnamese, Filipino, Laotian, and Cambodian Americans, they all end up falling under the broad category of Asians when it comes to sort of applying to like graduate school, fellowship applications, and jobs. But their experiences in the United States often vary greatly in general from other Asian groups that are sort of not underrepresented in STEM, like Indians, Chinese, Japanese, and Koreans, for example. So, a quote from the article, which I thought was very interesting, that sort of summed up the situation well, was from Janelle Wong, who was a professor of Asian American Studies at the University of Maryland. And she said, while they, regarding Asian groups that usually aren't underrepresented in STEM, do often face implicit bias on campuses, they're not facing systemic exclusion in access to higher education. So they go on to give an example specifically about Filipinos as they experience what's called downward intergenerational mobility. So the article says that this means that US-born Filipinos are actually less likely to obtain a bachelor's degree than their foreign-born parents. So programs and efforts that boost and lift up groups that are often underrepresented in higher education STEM should include groups like Filipinos and other Asian minorities that have sort of this downward intergenerational mobility, but they often don't, as they're categorized broadly under the Asian category. So the article goes on to talk about how this actually doesn't only impact higher education and sort of the workforce, but also other fields such as medicine, since Filipino women have high rates of hypertension and diabetes and other risk factors that can impact childbirth, but they're actually rarely considered for the types of resources that are needed for safe birthing and pregnancy, since they are also grouped under sort of a broader category of Asian. So yeah, so the article says that a way that we can sort of solve these issues is through data disaggregation in the Asian community, which means that we would actually collect more specific data on Asian subgroups rather than just grouping people together from the entire continents as sort of like an Asian category. So yeah, that was the article that Kyle sort of linked to us, and I just wanted to highlight that. I thought it was really interesting, especially from the perspective as one of the groups that isn't underrepresented in STEM as an Indian. I think that quote from the University of Maryland professor really did sum it up well, as I have found that I've faced like implicit biases on occasions, but as I'm not like systemically sort of excluded from the field because of my ethnicity, which is something that other minority groups within the Asian community do feel. And Kyle talks about this in his interview. So yeah, that was one thing that I sort of wanted to highlight before we get into his interview. So yeah, Simi, have any other thoughts?
Not really. I think you sum it up well, and Kyle talks about it a little more in depth about the reasons that he thinks that this is the case. And it's really interesting to get his perspective, especially as someone who is really part of the most minority, one of the most minority groups in STEM. So yeah, I hope you guys all enjoy talking or like listening to our conversation as much as we enjoyed having it with him, and that you can all get some good takeaways as well.
Yeah, so we'll get right into the interview now. So thanks everyone. Hey, hi everyone. Welcome back. This is now episode 8 of Cosmos Crusaders, and we're very excited to have Kyle Kabasares on the show. Kyle is a PhD candidate in the physics and astronomy department at UC Irvine. He already got his master's in physics from UC Irvine, and he graduated from UC Merced with a bachelor's of science in physics. And he also has a very popular YouTube channel, which we will also get into. So yeah, welcome to the show, Kyle.
Thank you for having me. It's a pleasure.
We're just, oh, well, thank you. Sorry, I wanted to say thank you as well. But we're just going to start off by talking a little bit about your research. So we know that you kind of study black holes, but that could be super broad. So why do you mind like telling us more about the details about it?
Yeah, of course. So I guess the simplest way I could describe my research is that I weigh supermassive black holes. Typically, I study the most massive kinds of black holes, the supermassive kind, in the most massive types of galaxies. So actually, the picture you see, I guess over here, that's one of the galaxies that I weighed its central black hole. And typically how you do that is that these galaxies, we've sort of looked with the Hubble Space Telescope, and we've seen that they have these really round and smooth sort of dust and gas disks at their centers. And a good portion of the time, or maybe not a good portion, but some portion of the time, these gas disks have really nice, clean rotation. And we know from like introductory physics that if you have like a massive object, like for example, the sun, and then you have smaller objects like planets orbiting it, you can infer the mass of the big thing, like the sun, based on the motions of like the planets. And so same principle applies where we have, my case, we have gas that's rotating around the black hole, and we can use the speed of that gas to work out how massive it must be.
Yeah, that's really interesting, Kyle. I got a very detailed presentation of your research at AAS a couple of months ago. So
I remember.
yeah, you did a really good job on that iPoster. So that was awesome to hear. So yeah, I guess I was wondering, I know that you recently published a paper. So if you could sort of get into what specifically you found in that paper and the results.
Oh, yes, of course. So it's funny you mentioned that. I actually have a copy of it like right here. Oops, sorry, I made my thing. But I don't know if you can read the title, but it says Black Hole Mass Measurements of Early Type Galaxies NGC 1380 and 6861 through ALMA and HSC Observations and Gas Dynamical Modeling. I know it's a very long title. NGC 1380 is the galaxy you see back there. So yeah, basically these two galaxies were studied by pretty much the last person in our research group at UC Irvine who got their PhD. And what he found was that these galaxies contain, like I said, these sort of round and circumnuclear rotating gas disks at the center, and determined that these two galaxies would be good candidates to weigh their black holes. Just as a bit of an aside, why would people even want to do that? There's ideas in astrophysics that black holes and the galaxies that they reside in influence each other's life and grow together throughout the age of the universe. And one indicator of that is the masses of these black holes are correlated. There are these sort of relations that connect the mass of the black hole to several large-scale properties of the host galaxies. And so getting reliable mass measurements is important for us to understand the fundamental connection between black holes and their host galaxies. So that's just as an aside. But for these two galaxies, these two actually were kind of interesting in different ways. So both of them have quite a bit of dust in their center. And one of the things that you need to do when you're weighing a black hole is you need to have a model for essentially pretty much the mass of the galaxy it resides in, at least for the innermost part. So the way that that works is that we typically take a Hubble Space Telescope image, kind of like the image you see behind me, but maybe in a different filter. And we try and model how bright the center of that galaxy is. And that's how we create a model for sort of the host galaxy. And then we have to essentially correct for the presence of dust. So you can probably see there's like this dusty ring in this galaxy back here. And that was actually the thing that took the most time for me to deal with, because dust is a notoriously complex thing to model in astrophysics. There's a lot of just complicated equations and just really complex models you need to really get all the details right, which I didn't actually do, but no one else really has in the field. So when it comes to making these measurements, so I think I'm okay with that. But yeah, essentially I had to figure out how to like really handle, accounting for this this amount of dust in the center, because if you don't, you get very different answers for black hole mass. Like the uncertainty on the measurement for NGC 1380, for example, was about 40%, which is better than past measurements of other kind of galaxies, but not as good as in the best cases. But that's kind of the point of my work, was that this is a big uncertainty in measuring these masses, sort of the presence of dust and how it could influence the final measured value. The other galaxy, 6861, had another interesting feature, was that it just didn't have any like gas in the center at all, as in there's gas, but it's not like very close to the black hole. And so in that case, we still could build a model to try and explain its rotation, but the range on the black hole mass was quite large. So pretty much got anything between 1 and 3 billion times the mass of the sun. So that's like a factor of 3 difference. There was a previous measurement that said it was about 2 billion. So I guess my big range did encapsulate the previous measurement. But yeah, that's sort of the main takeaways of this paper, I think. It was it's not so much that these are very precise measurements, but more so explaining why they're not so precise, and sort of pitfalls that you can run into if you try and measure black holes in these systems.
That sounds really interesting, and probably going to be really helpful for like the future of the field when people try to work on the same stuff as you. So that's awesome. But for me, like, I'm not an astrophysicist. So I just have like some trouble conceptualizing like how big these black holes really are. So like, what are some, like, how do you describe that? What are some of the smaller ones that you've seen? What are the bigger ones? And like, how do they relate to like Earth or something more visible, I guess?
Yeah, that's a really good question. I wish I had some numbers offhand, because I did this calculation like not that long ago. But effectively, like the smallest black holes in astronomy, at least, that and I don't study them, but the smallest kinds of black holes would be stellar mass black holes. So those are black holes that have a mass comparable to like the sun in our solar system, or a few suns in our solar system. And right, sort of when we think about sizes of black holes, I think the characteristic property most people think about is sort of the size of the event horizon of a black hole, which unfortunately I don't have that off the top of my head for like a solar mass black hole, but it would be it's pretty it's, well, I know the formula for it. I'm not even going to try and give you a number, just because I feel like I'll totally mess it up. But these, I think this is actually an interesting point to make, because one of the important features for making these measurements, at least for the supermassive side of things, is that we really need high resolution, as in we need really big telescopes to see that close in to the centers of these galaxies. And so I don't know if this is helpful, but essentially you need to be able to see on scales pretty much where the black hole like influences the stuff in its vicinity, like by its gravity. And even for like the quote unquote nearby galaxies, by nearby still I mean that's still like millions of light years away. In terms of like a size that's projected on the sky that we need to be able to resolve with telescopes, that's about 0.1 arc second. So an arc second is what, let's say 1/4000th of a degree, and so we need 1/10 of that on the sky. So it's a very, very, very small angle on the sky. But even these massive black holes, that's kind of the region in space that we have to be able to look at to see the effects of their gravity. So I wish it would be more helpful with Schwarzschild radii, but I just don't know them off the top of my head.
No, it's all good. I think for a solar mass black hole, it's like on the order of like kilometers or something like that. I don't know, because we just went over it in class today, because we're studying literally today, because we were studying accretion disks in our high energy class. So
that's sick.
Yeah, I think one of our problems was like look at a solar mass black hole, or he was talking about a solar mass black hole, and then he said something about the Schwarzschild radius being like something on orders of kilometers. So I think it's like that.
I know for like the Earth, if you turn like the Earth into a black hole, you have to shrink it down to like a centimeter, or like the size of like a peanut or something like that. That's kind of like that's kind of like what the source field radius would, like how much like mass you have to stuff into to get a black hole, if it's like an Earth, if it's got an Earth mass of stuff. So yeah, it's the scales are actually not that big. It's the mass that's the impressive part, I think.
Definitely. Yeah. So yeah, your research is really interesting.
Thank you.
Yeah, definitely. I want to read your paper when I get a chance. I haven't got to it yet, but I'm excited to, especially after hearing your presentation.
Oh, appreciate it.
So yeah, so now we're gonna get a little bit into your background. So I guess when did you know that you wanted to study astrophysics?
Oh, this is a really good question. There's actually like two distinct points in time where I kind of wanted to do it. So the first time was in high school. I read Stephen Hawking's A Brief History of Time, very popular and famous book he wrote that is for like a non-technical audience. And it was explaining sort of his work on like cosmology, expansion of the universe, the Big Bang, black holes, that kind of thing. And I was just taking my first physics class at the time. I believe I was like a junior in high school. And I was just really like, oh, this is so cool. Like, this is really awesome how physics can be taken from inclined planes and dropping balls off buildings to like studying the universe and its expansion and black holes and stuff like that. But then when I went to undergraduate, I did a general physics degree, but there was no astrophysics courses or astronomy courses at UC Merced at the time. There now is, but when I went there to undergrad, there wasn't. So I just didn't get a chance to really study like that kind of material. And so when I went to graduate school, I actually went to graduate school thinking I was going to do like condensed matter, like nanomaterials, quantum materials kind of stuff. But then I just realized I didn't really like it as much as I thought I did, especially because now I had the opportunity to study astrophysics finally. So it was like probably sometime early in the first year of graduate school where I kind of just switched from thinking I was going to do like the experimental condensed matter route and just being like, oh, I want to study black holes now because I've never had a chance to learn about them before, and now I can, so I will. Yeah.
That's awesome. I'm glad it worked out in the end. It's so crazy that you went in though, like not really like knowing for sure or kind of having your eyes open. I feel like that doesn't normally happen for people. So I'm happy that it worked out for you. But how was it like growing up Filipino? Like I personally don't know any Filipino astrophysicists. So how did that impact you? And like when you see the people that are in the field with you and you notice like the lack of representation, not just of Asians, but like Southeast Asians specifically, how does that like make you feel, and why do you think that is the case?
Yeah, that's a great question. I will say, even though there is not that many of us out there, that I have been fortunate enough to connect with some of the current, Filipino astrophysicists out there at all levels. So just to give shout outs, if I may, got a shout out like Flip Tenedo over at UC Riverside. He does technically dark matter stuff, but I think he'd consider himself a particle physicist, but still awesome. You've got Dr. Mia de los Reyes, who just graduated from Caltech, who's now at Stanford. There's Drea Carrillo, who I believe is now postdoc in Durham. So she's a doctor now as well. Sabrina Berger over at McGill, she's of Filipino descent, doing stuff with CHIME, which is a radio array. And then I'm sorry if I'm going to forget someone. I people watch this and feel mad. I'm so sorry, but I'm doing this on the spot. And then of course there's Hillary Andalas over at MIT, who's an undergraduate finishing up her undergraduate degree. And I've had the pleasure of connecting with them either through in person or over social media. So I think that's been awesome. But to get back to your original question in terms of, growing up and not really seeing others like me in the field. I mean, I think I definitely found it discouraging at times. I would say that I didn't face perhaps just outright maybe discrimination when I was majoring in physics as like an undergraduate at UC Merced. I occasionally maybe would get some comments like, oh, you're not someone who I would think would study physics, you're not someone who kind of looks like who would do physics, that kind of thing. But nothing, thankfully, more extreme than that. But definitely just tried to just do the best that I can and be a role model for others like me. And as to why I think there isn't more of us out there, I can't really speak for maybe all Southeast Asians, but I can say from like a Filipino background, I think just there are maybe a couple of cultural factors that play into that would make it maybe more difficult for someone in this of this descent to pursue this career. So for example, I think as in a lot of cultures, like family is such a really big part of the culture. And back in the Philippines or even the United States, for families that have immigrated, there is usually maybe multiple generations living under a roof. And so it's maybe not so encouraged for someone to just sort of go off and pursue an advanced degree somewhere else for 5+ years and then go and try and secure an academic job that takes much longer, far away. So I think that's one key obstacle. I think also there is, unfortunately, I can see this in my own family. There can be conversations that might discourage someone from pursuing a degree that might not have maybe just inherent value, just in terms of like getting a really good job afterwards. Like if people might think, if you study physics, why don't you just do like engineering, or go and be a doctor or a lawyer? There's definitely been conversations with my family, not to me directly, but with people I know who have been discouraged from pursuing certain careers because they have been seen as not having that much utility. So there is sort of that aspect to it as well. And I just have to say that I think I'm actually quite fortunate because I didn't really have those pressures on me. I think I was lucky enough to have a family who encouraged me to just study what I thought was interesting and not try to influence my direction one way or the other, and not pressure me into being someone I didn't want to be. So I think that's one key reason as why I've been able to do this. But I understand that it's not that not everyone has that scenario, and I hope that it gets better over time, because I think that we can definitely make a difference in this field.
Yeah, I hope so too. I'd love to see more Filipinos and Asians in general just be in the field, because there's so much that we can provide. But you mentioned earlier that you just studied physics at Merced because they didn't have any astronomy classes. What was that like for you? Like, did you actually enjoy your time there, even though you were studying something you weren't super into? Or like, were you able to join clubs or anything that was about astronomy?
Yeah. So I would say I still found my major very interesting. Like I do love physics to its core. Like it is definitely the subject that, and of course, astrophysics and astronomy is a part of that I now specialize in. But I found the major quite enjoyable because I think it was the least populated major in all of campus. I think you could fit all of every physics major from all 4 years onto one sheet of paper, like one side, which is kind of interesting. So it was a very small and tight-knit major. You got to know everyone in your year, in the years ahead or before you, and the class sizes were very small. So the professors were like very easily accessible. We were a very close group of students. Like my graduating class, I think, had 6 graduating physics majors. So, we had been through all of the sort of upper division classes together and gotten to know each other very well. And, I didn't really, like I said, there was no astronomy there whatsoever. And now that I think about it, there was a class that was offered once every 3 years on like modern astrophysics. And it was supposed to be available my senior year. So I thought I would have one chance of like, finally get to like study like astrophysics finally, just one time. And then they couldn't find anyone to teach the class. So it didn't end up happening. So yeah, I mean, I was part of the Society of Physics Students, which is an organization for physics students to bond over physics and do outreach and communicate our interest in physics to a wider audience. But yeah, there really wasn't any like astronomy specific stuff for me to do at Merced at the time, but it didn't stop me from going into it in grad school.
So you also had two very different research experiences during your undergraduate career. So you mentioned that you did condensed matter physics research at UC Merced, and then you also had a NASA internship. So can you describe your experiences doing both of these research projects and sort of your takeaways from them?
Yeah. So I did condensed matter physics for about 2 years, starting like in the summer between my second and third year in undergraduate. And that pretty much was like the group and the research I did until I graduated. So it's been a while, but essentially what I was studying was I was studying these two different materials. One of them are called quantum dots. These are these like nanoparticle objects that will emit a very specific type of light. So they're pretty much made of these chemicals that when you shine like light on them, they will emit light of a certain color. They're used in like LED TVs. Now I guess there's like quantum LED TVs these days. I'm not so sure. That's what I would always bring up as application at the time. So there's these quantum dots, and then there were these other materials called liquid crystals, which are like kind of this quasi other state of matter between like a liquid and a solid, where you have like not as random of like molecular disorder as in a liquid, but you have less order than you have in a solid. And essentially what I was doing, I was putting these quantum dots into these liquid crystals. And the reason why I was doing that is because the applicability of quantum dots comes in when you can sort of arrange them in specific geometries, if you can get them to form in certain shapes. But because they're like very small, it's really hard to just manufacture them in certain specific geometries. And it would have been much easier if you can just get something like something that's very malleable and tunable in terms of a shape, like a liquid crystal, which responds very well to like electric and magnetic fields, or if you put it on like a hot plate and change the temperature, it'll change its shape. And so I spent like 2 years putting quantum dots into these liquid crystals, and I would, I feel like I made dozens, if not hundreds of samples that took like 12 hours to make start to finish, which was just like brutal. And, I think the thing I took away from that experience, even though it ultimately was not the thing I continued doing in graduate school, it definitely pushed me out of my comfort zone because for the longest time, I just didn't think I could work in a lab setting because I don't know, I've never been that confident in my like ergonomic skills of like mixing chemicals and using hot plates and using an oven and all this kind of technical equipment. But I did it for 2 years somehow. Got better at it, but I don't think I ultimately found it to be the thing that I wanted to do forever. And I think that's okay. I think I took away that it's definitely fine to like try something new, push yourself out of your comfort zone, and just push it to as far as you can take it, really. And so I wrote a whole senior thesis about it. I don't really know what my group did with the work I did afterwards, but it was definitely a learning experience, and it was my first ever research experience, so like taught me just the trials and tribulations of being stuck on something and having to work through difficult times. One of the interesting things I don't really miss as experimentalist is like you're very limited to like the materials you have available in labs. So like I remember there was like one period in time where we were running low on like a certain chemical, and like but everyone in the group kind of needed to use it, so we had to like ration the use of this chemical. It was like, yeah, we can't order this chemical for like another month, so everyone has to just like make do with like 20 milliliters of whatever this was. And I don't know, it was just funny to have those constraints on me, which I don't have really in astronomy. So that's one thing I don't really miss. But the second experience was in between actually the first one. So I did a internship in the NASA Student Airborne Research Program, which is acronym is SARP, and that was in between the summers of my junior and my senior year. So that was just one summer after the first research experience, and that was also something like just completely out of my area of comfort, which was I did research that summer on atmospheric chemistry. And so I asked a question because we were kind of tasked with like, come up with a research question that you would like to try and answer with like available NASA data. And at the time, we were just getting out of a pretty bad drought in California. I think it ended in 2016, but from like 2011 to 2016, there was a drought in California. And I was just curious, like the simple question I had was just like, how does drought affect pollution in the sort of the southern part of California, which is where we were at the time. And, you know, I think the thing that this experience taught me was of one of the many things, at least, is that you can ask a very simple question, but it'll have a very complex and difficult answer that you might not get to in just 8 weeks of an internship. But I was using these models in MATLAB, where I would be, MATLAB's this program that was very common apparently for NASA scientists to use in this program. And I was pretty much modeling the production of ozone, which, as you know, is important to our atmosphere. We always talk about like the ozone layers is healing or being destroyed. And one thing I learned is that there's so much chemistry going on out in the sky that is hard to it's really hard to say how the reduction or the increase of one thing, does it necessarily imply the increase or reduction of another thing? Because it's like you have all these different chemical pathways that affect each other. And, the thing though that was interesting about it was I ended up focusing on drought, right? Because that was sort of the initial question I asked. And I was thinking about how, drought just sort of like logically you think, okay, well, drought, that means a lot of plants are going to die if they don't have water, right? And plants emit quite a bit of chemicals that play a role in our atmosphere. So I was looking at the role of this one chemical called isoprene, which is a common plant chemical that is released. And I wasn't able to get my hands on that much data, but it did seem from what I was able to get my hands on that indeed there was a decrease in isoprene levels in that drought period, which maybe was not too surprising. I wasn't able to fully tie it into what I had done completely that summer by the end of the 8 weeks. But the cool thing is that actually one of my friends in the program who ended up staying with the same professor who we were working with as a graduate student, she ended up writing her first paper sort of on the foundation of how does isoprene play a role in ozone production. So that was actually ended up being the first paper I ever was a co-author on. And I had just no idea she had taken the stuff I had done a couple of years ago and now had turned it into a solid paper of hers. So again, just having simple questions can lead to really profound answers. And one thing I'd like to say about the program itself is that it was just so cool to be part of a program that brought in so many different kinds of college majors at the time. So they brought in I was a physics major, but my sort of little team of 8 other students, or 7 other students, there was 8 of us in that group, 32 overall, so there were 4 groups. But in our little group of 8, we had a couple of physics majors, a couple of chemistry majors, mechanical engineering major, geology, computer science. It was a real big collective of different skills and backgrounds. And it was so cool to see how everyone's different area of expertise really played a role in solving this really complex problem. And whenever I wouldn't know anything about the chemistry, I could easily just talk to someone in my group about, I don't know anything about isoprene, what is it? And that kind of stuff. Or if someone didn't really know how to use MATLAB, I had some experience with it. There was also a mechanical engineer who also used MATLAB a lot. So I remember having a lot of MATLAB tutorial sessions with people, just showing them how to use it. So that was really fun. I think that just the value of collaboration and teamwork in a diverse interdisciplinary team was just amazing. And I think that, I really value that kind of experience in my current research today.
Those both sound like such great growing experiences. And yeah, the NASA internship for sure cultivates like good work area, like workplace skills and collaboration skills. That's awesome. We're just going to move on a little bit to now your grad school like application process. What was that like for you? Just in general, why did you decide on Irvine? Where else did you apply?
Oh man, it has been a while, but I can tell you why Irvine. Irvine was the only school that accepted me, so that makes it easy in terms of choosing. It was a very difficult time, to be honest, in my life at that point. I think, well, I don't think I know. I mean, I was so someone in my family, a relative of mine who I was really close to, passed away like that fall during like the application period. So it was a very sad time in my life, and I was trying to balance, that as well as taking classes still as a senior, trying to work. I had a job at the time as an undergraduate, so I had a job. Still doing research in the experimental condensed matter lab, studying for the physics and the general GRE, and applying to like grad schools, trying to balance all of that. That was just, I don't know. I don't think I did that. Looking back, I would have maybe changed some things I did, but I think there were some things that were just unavoidable and like I couldn't really help. So yeah, it was difficult. I think though, yeah, I mean, in terms of like the application process, it was definitely one thing I will say, it was definitely tough to like come up. I'm having kind of the similar issue right now with postdoc apps. It's like coming up with like good ideas to pitch to grad schools and saying like, this is kind of what I want to do for grad school, and like this is the research I'm committed to doing for the next 5 or 6 years. And yeah, I think if I could go back in time, I would definitely tell my younger self to get more feedback on your ideas. And that's something I still struggle with today. Like, I don't know, I think it's imposter syndrome, but I think when you're a young scientist, you have a lot of doubt, perhaps in your own ability, and you can tend to maybe downplay your own intelligence and abilities to the point where you are just almost sort of afraid of like trying. So I definitely didn't give myself the chance to get a solid feedback for all my apps as I should have. So I actually consider myself lucky that I was still able to get into graduate school somehow during that period. But yeah, that's what I remember of it at the time.
Yeah, that sounds really difficult, and I'm really sorry to hear that your relative passed. And yeah, just imagining juggling all of that during the grad school process, which I mean I went through 2 years ago now, almost, which is kind of crazy. But yeah, that was also a really difficult time for me, and just having everything that you had going on in addition to all those apps sounds really difficult. So I'm sure you did as best of a job as you could have.
Appreciate it.
So now getting into your time at Irvine, you've spent quite a bit of time there. As you said, to graduate this year. So what were some of the hurdles that you had to overcome during your time at Irvine, and also some of the milestones that you reached during your time there? Could you sort of share some of your experiences?
Yeah. Yeah, this is a good question. In terms of like hurdles that I've had to clear, I think one of the biggest hurdles was just switching into like astrophysics, having absolutely like zero like experience in it. I thankfully had an advisor who was very encouraging, and I just told them, look, I don't have any experience whatsoever, but I'm willing to learn. Do you have any advice for me? Because he was looking for a new graduate student at the time, because his current one was graduating that year. And so he just told me that if I'm really interested, here's a book, here's like some papers, dig into them a bit, take this class with me in the spring, and then we'll see where it goes. So I was very fortunate that my advisor, who interestingly enough also didn't really have that much astronomy experience going into graduate school himself, was willing to take a chance on me. And I remember also him asking if I had a lot of experience with Python programming. And I mean, sort of I kind of did, but not really. That's probably to the level that he thought I did. So that was also a little bit like of a challenge to just sort of teach myself like a new language from scratch to, this project he gave me. So I think taking the class with him and doing well in that class with him was definitely one hurdle that was clear that I was really happy about, because I knew nothing before. It seemed like everyone in the class had, they had been like an astrophysics or astronomy emphasis, for their undergraduate degree. And so just learning, like I had never heard of what like a color magnitude diagram was, or like what a globular cluster was, or just these terms that are just thrown around in astronomy that I just had no idea. So that was definitely a hurdle. I think one other hurdle I had to clear, which was like towards the I think it happened during the summer of the first summer after my first year in grad school. So I just taken the astronomy class. I was just starting my PhD project that I was new to everything. And then I was playing basketball on, I remember the date, it was July 5th, 2018, because the day before was July 4th. So like that's why it was easy to remember. But I was playing basketball, and then like I tore like a muscle in my left leg, and it was just really devastating. Of course, I mean, it hurt. And it pretty much set me up for well, I had to get surgery, and then I had to like do like a year's worth of physical therapy just because I wanted to play basketball one day. So that was definitely a hurdle, trying to like balance like recovery as well as still, trying to contribute to like this research project that I was given, and still taking classes in my second year. So that all culminated in, I guess, a little bit later, like almost a year later after the injury itself. Like one of the biggest first things I had to do for my research project was I was trying to build this program in Python that would reproduce an already published result. And it was I still can't even describe how like satisfying it felt to like see that my program was getting that like published results. So this was probably like in, I think, March of 2019, I think. Yeah, it was like almost a year of working, because I started in the summer before. So it was almost a full year, like probably like 9 months of trying to get to at least this point. Like, can I get my program to like, generate a published result before I can start applying it to like newer data sets, so I can, generate my own results, like in this paper, for example. And I remember the moment where like, it was funny too, because I remember there was like a false moment of like joy where I was like, oh, I think I got it. And it was like really satisfying. But then I like looked over my code a bit more, and I realized I didn't actually do it right. And I was just like, oh my gosh, like, no, like I thought I had it. I even told my advisor I had it, and I was like, oh no, I was wrong. And so I was trying to figure out, okay, can I actually do it now? Can I actually fix this and get the thing I need? And I did. And it was just like, wow, like that was kind of the first moment in grad school where I was like, yeah, I can do this. Like, I can do this. So that was definitely a hurdle. And I don't want to spend too much time on the rest of the things, but I guess some milestones, I'll just briefly say them. A lot of them happened before COVID. So been able to travel a lot to some pretty awesome astronomical observatories, and learn like data reduction techniques, actually observe on these telescopes. So for example, 2020 in January, I went to like Hawaii for like 2 weeks, got to like go visit like Mauna Loa, got to visit the submillimeter array, got to help out on an observing run at Gemini Observatory. Also had a chance to visit the National Radio Astronomy Observatory, not in Hawaii, but on another trip. So I've just had the good fortune of my advisor being very encouraging, to be like, hey, this is something you should probably consider. This will definitely broaden your skill set. You'll learn a lot more than just, staying in Irvine, get hands-on experience and stuff. And so I think definitely getting to travel has been a highlight. Milestone publishing a paper, of course, that's a big one. And yeah, I think that's pretty much it. I'm sorry, I didn't mean to take up so much time with that, but there has been a lot for sure in 5 years.
Yeah, you're good. Don't worry. We love to hear about accomplishments, and we're really proud of you. And it's so awesome that you're almost done and like you can look back on everything like this. It must be crazy feeling right now, but
It is.
it just shows that all your work and dedication paid off. So that's awesome.
Thank you.
Of course. Yeah, at Irvine, you were a mentor for the CalBridge program, I believe. And so you've throughout this interview have been stressing the importance of like mentorship and support network. So what have your experiences been like with CalBridge, and like is that something you would like want to continue doing, the mentorship aspect?
Yeah. So CalBridge is, just for people who are not aware, CalBridge is a program that helps students at the California State University schools have research opportunities. They pretty much get to do summer research at a University of California school, because Cal States are typically not known for having a lot of research opportunity. They're more for getting students out there into the workforce. And then like the University of California schools are typically more research oriented and have more research opportunities. And so we take the program funnels students from the two schools. So I've had the opportunity to have three summer undergraduate students who've pretty much wanted to do work on black holes in our group, and essentially got paired with me to use the tools that I've built to weigh supermassive black holes. And so I will say that one of the papers that I'm really close to getting out, hopefully by October, is a paper that used a lot of the work that was done by two of my former students, where they were like the first people ever to weigh the black holes in these two other galaxies. So I think it's just been absolutely awesome to, see these students, go from maybe not being very familiar with our research, and then, being able to, teach them and show them how, the tools I've built work, and then just letting them go off and, weigh these black holes. It's just so gratifying. And I think the next paper I'm going to publish with those results is going to be like my favorite one in all of grad school, honestly, because it's going to involve them. So yeah, I mean, I've been a research mentor for CalBridge. I've also been a tutor during the actual school year for a couple of students who, need some just extra help with upper division physics classes. And so we'd meet, once or twice a week, and we'd go over, I'd make a lesson plan, and we'd go over the material they've been studying. And, it's awesome that they have this resource, because, I think it really goes to show, and I always stress this when I'm teaching students, that it's like the first time you see it in class, it's like, don't feel bad if you don't get it. Like, it usually takes me several times to really fully understand something and understand in a way that makes sense to me. And then challenge is trying to communicate that to them. And, I've had some of these students. I mean, one of them is now a PhD student at UC Irvine now. And I remember them telling me that, with like my tutoring sessions, it really helped them get through those last few years in undergrad. So it just, those are the kind of the moments, as an educator, you just really love, and, that's what you strive for.
Definitely. That's awesome. Yeah, and it's great that those results are going to go into an actual paper. So I'm sure that feeling is really amazing. So yeah, that's really awesome to hear. So now getting to your YouTube channel. So we know during your time in grad school, you started a YouTube channel that is very successful with almost 3.5K subscribers. So what was it like creating this channel? And what have you sort of taken away from it?
Yeah, I would be a little bit careful saying very successful, but maybe that's just me just not wanting to brag about it. But it's interesting. I started this channel same time when I got hurt, actually, because I was just stuck at home, like all day, sort of recovering and waiting for like physical therapy appointments, but I just couldn't go out that much. And so I got this fairly nice camera that I've always been kind of into like technology and like camera and microphones. I mean, you can see this right here. So I've always been interested in like film and video making from a young age. And so, just having all that free time to just sit around and just think, and think of video ideas. I initially started out by just making like videos of me like solving physics problems because, as you know, I like to teach. Obviously, I was a tutor. I think video and like education through resources on the internet now are really huge, and I think we're still not quite taking full advantage of what's possible in terms of revolutionizing education for on a bigger scale outside of maybe the traditional sort of school system. But anyways, I just really wanted to just try my hand. I'm like, yeah, I like watching like Khan Academy, for example, when I was younger. So I was like, I kind of want to make my own kind of videos, just see how that goes. And I think the process of making videos has really allowed me to tap into sort of like the creative side of me, because that's something I feel like I didn't really get to express so much maybe my first year in graduate school, because I was just sort of taking classes, trying to study for like a very hard test at the end of the year. There really wasn't a lot of time for me to do things outside of just always thinking of physics. And in a funny way, the video still made me think about physics, but in a, I guess, much more enjoyable way. And I guess having the initial feedback from people saying, hey, I really like your videos. I'd make videos on like just things I found interesting in physics. Like, I don't know. I like to I like really old books. So I have a lot of like really old books I have. And I would just, buy these books and be like, this is a good book, or this is not a good book, or why do I like this book, or I like solving a problem out of this book. I'm a big fan of history. This is a funny story. I almost majored in history in college because that was my favorite subject in high school. And so had a little bit of a chance to insert like physics history here and there in some of my videos. One of my favorite videos that I've made is like on the story of Subrahmanyan Chandrasekhar, who won the Nobel Prize in 1983 for his work on white dwarfs and stellar evolution, but how his idea at the time was really like ridiculed by the sort of the top people in astrophysics at the time. And the story was just really compelling to me, and I really wanted to make a video kind of going through the timeline of that whole ordeal for him, and inserting some just some educational bits about physics, but like what did he actually discover. And I just loved looking through all the different primary sources of historical accounts of interactions between him and like Sir Arthur Eddington, who was like the main guy, just not really buying into his ideas. And yeah, I mean, I think it's definitely my channel is definitely varied. Like I have videos of all different kinds. I mean, that's one of its own kind. I have vlogs on there. I have skits of me just portraying like moments in graduate school that are funny to me. And then of course the book reviews. But I think the channel has just taught me to really just embrace being myself, and just being willing to put that out there and willing to take whatever comes my way, because obviously I think you really can't please everyone in terms of being a content creator. There's going to be people who just don't find your style of videos entertaining, or they don't like your humor or whatever. But I just keep trying to remind myself that there is an audience for what I do, and I'm doing it for them. And I think it's great that I have this outlet, honestly. And it's been I've had to connect with some awesome people through it in physics. And so I hope to keep making content. I've kind of slowed down a bit in the past couple of months, just because it's gotten kind of crazy right now during job search time and teaching, and still doing research and writing a dissertation. So I would like to continue it for sure.
I hope you continue it too, because that does sound like a really nice outlet, and to just have all your interests like in one place. So I hope you can find the time eventually.
Me too.
So it seems that you're kind of starting to like wrap things up on that last paper, and things are kind of moving forward with your thesis. So like, what are the final steps that you have to take within the next year to sort of wrap everything up?
In terms of just the research side of things, apart from like wrapping things up as like applying for jobs is one thing that has to get done and having a position to go to afterwards. But besides that, yeah, I mean, now that the framework that I've built in Python has now been successfully, been tested, and it's, I have a published work out there on it. I have the fortune of, we just have had a lot of data collected over the past several years since I've been part of the group that just has not been able to been pushed through my program yet. And so when I first started this project, like 4 years ago, actually, because I started at the end of my first year. When I first started this project 4 years ago, my advisor and I were talking about all the different like features we'd want my framework to have and how many data sets I'd want to like probably do by the time I was done. And as with most plans in graduate school, things didn't go quite according to plan. But that's okay, because, I still have a lot of data sets that I can push my, I can put through my program. And I'm in sort of the fortunate position where it's not so much that I'm worried about having a thesis done. Like I definitely feel like, the work I have published now, and then the paper with the 2 undergraduate students that I'm hoping to write, which will probably not be the last paper I write in grad school, but it could be. They'll definitely be part of the thesis. And then after that, it's really a matter of how much of the original plan can I get done before June 2023. And, having talks with my advisor, it's not a problem that I didn't do everything in the plan. I mean, it's, you have the plan there, but you don't necessarily have to like meet it all the way. So my own personal goal is to try and publish at least 2 more papers before I graduate. So I have one that's almost finally written up. That's with the 2 other students. So that will be submitted hopefully in October. And then the last paper possibly is going to be a black hole mass measurement on a galaxy that my own advisor measured the black hole of a few, like 20 years ago now at this point. And we're going to do a comparison study. And I'm really excited to do that, because that's been one target I've been hearing nonstop since I started the program, how that would be a great, comparison to use sort of the techniques I've developed throughout my PhD and compare it to what my advisor did back in 2000, 2001. So I guess if you're writing a story, that would be a very fitting final project to do in graduate school. But if there's time, I would love to apply my code to more data sets, but that's most likely where things will end by the time I'm done.
Yeah, that sounds awesome. So good luck. Very excited to look forward to your new papers and the results that you're going to find in them. So now looking a little bit into the future, so post PhD, do you have any plans? You mentioned earlier that you're applying to postdocs. So do you sort of see yourself staying in academia or moving in industry or a different field? So what sort of do you sort of imagine the next couple of years being like for you?
Yeah, thank you for this question. I actually wanted to bring this up because people have been following my Twitter over the past couple of months. They may have seen maybe a bit more of an emotional side of me where I've been a little bit pessimistic about staying in academia. And that has changed since about a month ago. I recently went to a conference with a black hole conference, and I met some amazing people in the field. Some of them were my collaborators who I just haven't had a chance to meet in person before. And it just kind of revitalized me in terms of just feeling like, I can do this. Like I belong here. And so I decided, because a month ago, I was like pretty sure I was not going to apply for any postdocs. And now I am like a few hours away from submitting my first one. So first app. So I give them all the credit for getting me back into the game, so to speak. But I will say that I don't really have strong feelings one way or the other. I've kind of just made it a personal decision to just give it everything I got this year and just live with the results, because that's really all one can really do. So I am definitely going to be applying for postdocs. I'll also be applying for industry jobs as well. There are also some education jobs that I thought were kind of interesting that I've looked at in terms of like maybe working at a museum as like a science educator. So I'm just really open to whatever is out there for me. And I just think that I'm just gonna just try my best at this academia thing. And I'm aware of all the potential pitfalls and the other options for me. But I just feel like I owe it to myself to just try as hard as I can to stay. And if not, then that's just what it is. And I'll be fine doing something else. I could make a whole maybe YouTube career out of it. I don't know. So yeah, that's kind of how I feel about it.
That's great. You really can't knock something until you try it. And yeah, your backup plans and your other options are still wonderful. So you're in a really good spot, and that's exciting.
Thank you.
But we're at the end of our interview now. So we're gonna close off with some quick hitters.
Okay.
So my first one for you is, what are your 3 favorite Filipino foods and your 1 favorite Filipino dessert?
Okay, so Filipino foods, number one's gotta be lumpia, which is like spring rolls with like meat and vegetables in them. Very classic Filipino snack. Second, I'd probably have to say chicken adobo, which is like this sweet and like sort of savory dish. So it's like chicken thighs or drumsticks, and you have like soy sauce, garlic, black pepper. My mom would make it a lot when I was a kid, so that's just a staple of my childhood diet. And then third probably would be this dish called pancit, which is like rice noodles, and you have like meat that could be like chicken or pork, shrimp even, and then also vegetables mixed in with that. So yeah, those got to be my top 3 that I like. And then in terms of dessert, I don't know, I've been eating a lot of ube ice cream lately, which has just been like so good. So yeah, ube, this purple yam thing that is really tasty ice cream when you make it into ice cream. So
those are all fire. Those are probably almost all of my favorites, Simi can attest.
There you go.
So yeah, so we also know the next question, we know you're from the Bay, and then so you're happy the Warriors won, so as was I. So yes. Who are your 3 favorite Warriors players?
3 favorite Warriors players. I have such a basic answer, but I think it's in an order that might surprise people. So in order, I think it's got to be Klay Thompson, Steph Curry, and then Draymond Green, which is like very surprising, I think, to a lot of people. I think the reason why I have Klay Thompson ahead of Steph is just because I think he's such an unsung hero, and he's very clutch. And it's like if Steph wasn't there, he'd be like, seen as like one of the best shooters of all time. But because he plays with Steph, he kind of takes a back seat, but he's cool with it. And he's just so versatile. Like he plays offense and defense really well, but I think he's overshadowed like offensively by Steph and defensively by Draymond. So people don't really think of him as like the main person for those reasons, but he's just all about winning. And so, I really think, he's someone I like to look up to, I guess.
I respect that. I really like Klay too, and he's very resilient. So
yes, and he also had an injury too.
Yes.
So I relate to that strongly.
Okay, next one. We know you're in Irvine. So what are your 3 favorite restaurants? You have so many options.
Oh man, this is so hard. Okay. 3 favorite restaurants in Irvine. So there is, I don't even know the name of it, but it's this sushi place that has like has the rotating sushi trays. Like essentially you can just grab stuff off the conveyor belt and like you eat it. I can't remember the name of it, which I'm really sad.
Is it Kura?
I think it is Kura. Yes, it is Kura. Yeah, so Kura sushi, it's definitely got to be one. I haven't been to it that many times, but when I have been to it, Hiro Nori like ramen is like so delicious. I wish I go there more often. I should just go there more often. And then third, man, this is so hard. There's a lot of really good places, but third, I already did a sushi place. I think I might go with there's a place called Amici's Pizza, which is also, it's probably my favorite pizza place in Irvine. So I feel like that has to be the third one because I love pizza. Like pizza is like pizza and sushi are like my two favorite foods. So it's like I have to have at least one of each on this top 3 list. Yeah.
Those all sound really good. I haven't had dinner yet, so
neither have I. So but you're much later than I am. So
so our last quick hitter is your 3 favorite facts about black holes.
Oh gosh. Okay, 3 favorite facts about black holes. Well, one of them is that I like is that if you were to fall towards a black hole and you went past the event horizon, people on the outside would take like an infinite amount of time for you to actually like cross like that boundary, because light would no longer like reach like the people watching you. Like you would just sort of fade into nothingness, but it would take technically an infinitely long amount of time. I like how they just, I don't know, I just like how mysterious they are. Like I just like how you can describe them with just 3 parameters, like mass, spin, and charge. It's just like you think they're more complicated, but all you really need to do is just specify those 3 numbers, and you kind of know everything you need to know about them and the environment that they occupy. And what else? One also thing I love is that they radiate, that essentially if you have 2 supermassive black holes that merge, or any size black holes that merge, they will produce gravitational radiation. And I will say, I was in a science writing class in like the winter of 2015, before the LIGO discovery of gravitational waves. And I remember being the only physics person in this class and talking about gravitational waves the entire semester, because that was the topic I had chosen. And I always had to say like, oh, well, we haven't discovered that yet. It's not like, we're still in the process of discovering it, but like, we're pretty sure they exist. And, I had a lot of kind of skeptic, like, oh, what are these gravitational waves? Like, that's kind of weird. Like, does it really bend space-time? Like, what does that even mean? And then like, 6 months later, LIGO comes out with the discovery of gravitational waves. And it was a very like validating feeling, just being like, yes, like, aha, take that, people, like the real. So yeah, those are the 3 facts.
Yeah, all really interesting facts. Yeah, thanks, Kyle. That is
no problem.
the end of our interview. So we really appreciate you coming on.
Appreciate you having me.
Yeah, learned a lot. It was great to hear your story. I now subscribe to your YouTube channel, so almost at 3.5.
I will too.
Oh, thank you.
Thank you. Thanks so much for coming again.
Okay. Yeah, no problem. Thanks for having the show.
Of course, Kyle. Thanks.